So standard deviation is basically the measurement of how spread out the graph is, right? So this is a spread it out, and this also is a spread it out. No, this is not as spread out, right? But this one is. So when we compare two graphs, we can say that this one has this A graph has a bigger standard deviation. And the Hung's question plays was that what about the range? Is there a correlation between the range and the standard deviation? If you have the range, for example, if you have this range, the range of from 5 to 10, and the graph is like this. And you have the shorter range from 6 to 7, and the graph, no, not 6 to 7, this to, let's say 5 to 100, and this is 5 to 100, and this is a 5 to 20, say, and this one has this shape graph. And the question is, if the range is smaller on this one, on let's say this A and this is B, if the range is smaller on the B graph, will the standard deviation change? Will the standard deviation of A or B bigger? So what Hung essentially was asking was that, can you draw a graph with a shorter range but with a bigger standard deviation, right? Was that correct, Hung?
Yes.
All right, so I'm going to give you one example for a graph which has a wider range but a shorter standard deviation, because essentially what standard deviation is not measuring the range, and that's why we separate those values. You have graph A, and you have from 5 to 10, and you have this. How about graph B? You have from 6 to 8, but it will be like this. In this case, 6 to 8, it has a shorter range, but it's more even, it's more spread out. So this has a wider it has a much bigger standard deviation comparing to A, which has a much bigger range, but it is concentrated to the mean. This is concentrated, so it looks a bit more grouped. It looks more like a bell curve, whereas on B, it looks a bit more flat. So this one has a bigger standard deviation with a smaller range, and A has a smaller standard deviation with a bigger range. And the otherwise can happen. I'm gonna give A in even shape like this from 5 to 10, and B a slope like this from 6 to 8. It'll be like this. Look, if you just limit from 6 to 8, you limit the range from 6 to 8, you can see that this still makes a bell curve, a bell curve shape. So this is still has a much smaller standard deviation compared to A. So recap, you can always draw shorter range, bigger standard deviation, and vice versa. All right, that's a good question, and I took a bit of time to just to make a sense out of it so that I can explain it again to you. Have you got that, Hung? All right.
Yes, I got it.
Okay, so that's cleared up. I will briefly mention our classes policy is that the homework is the most essential thing, because I can see that not everyone has done homework on due. And it's okay for this session only because I've switched up the schedule a bit, but I would expect you to finish this one in the next 48 hours so that I can see where you're going. Even if I just fixed everything already, I want you to have your take on it, and I want to see your input on this, and I want to see your result. Homework due in 24 hours. Okay, so why is that? Because I would expect you guys to do the homework before due about 1 day or 2 days so that I can just prioritize and personalize your course for you. But if you hand your homework, say 3 hours prior due, I wouldn't be able to change my I wouldn't be able to change my my documents. I wouldn't be able to personalize the course for you. So if you want your input to be recorded and you want your input to be personalized, to be included within the class, please finish your homework before due 1 or 2 days. Okay, my homework is not too much in the sense of it's the SAT. You can just put in 2 hours 1 day and you can finish all of them for 1 session, of course. So try to prioritize doing your homework first before doing anything else, so that I can have your input, so that I can just personalize the lessons for you. Okay, so this is because of the switcheroo of the schedule, so I'm not going to count this one. But in the next 24 hours, I would expect you to hand all your homework in, even late. Okay, I want to see you doing it. All right, so even if you see the answers to this already, our homework today will be for March US and May international, and there's a handful of new knowledge which I would like to cover, and we will walk from section 4 to section 3, because on section 3 is quite important and I don't want Lina to miss it. And so we're going to do lesson 4 first. Okay, this I'm going to walk in firstly the third question, which is it's very simple but it's weirdly phrased. For line segment AC shown, the length wait, let me open my document. Okay, for line segment AC shown, the length of line segment BC is 2 times the length of line segment AB. This is one example of a linear graph. Linear equation, it doesn't always have to look like this to be a linear. It doesn't always have to be a graph to be a linear equation. It can be in any ways. This is what they call a word problem, a real-life problem or word problem, which means that they just give you context and you make sense of that context by consolidating them into one equation, 1 or 2 equations, 1 or 2 linear equations. They don't make you to remember the quadratic equations yet. On the quadratic equations, which is a polynomial with the power of more than 2, 3, 4, these are the kinds of questions you will encounter on a polynomial with the power of more than 2 or more. These are the kinds of questions. But if you find the word question or any more complicated one, they'll mainly be the linear one, because it will be a bit more difficult to do it in quadratic or the cubed equation or anything like such. So focus on linear equation and how to solve them, how to convert the lesson, the prompt, the question into the linear equation. Here, you can see it's very simple. For line segment AC shown, the length of the segment BC is here, is 2 times the length of AB. Which equation represents this situation? So you have BC is 2 times AB, which means BC is, or 20, is 2 times X. It's very simple. This is just a very simple example, but I want to make clear of it. Why is that incomplete? 3D. Okay. This is, I believe, is 0. Yeah, this is equals 0. There's a typo here. So it's that simple, but you're going to have to understand what the question is talking about. And also, yeah, I will save that later when Lina comes, but I will cover how to do your maths question a bit more quicker, because I find that in our class, accuracy is not really a problem. The problem is time. You guys do it in such great accuracy, but in short duration of time. And I find that either you guys just do it over time, or just do it twice, or in the exam, I can see that you guys do it twice, or you guys do it over time, or anything like that. But the accuracy is undoubtedly accurate. It's good, but you need to focus more on your time, because on the SAT, you not only do you have to worry about the accuracy, but you're going to have to worry about the time. you only have what 30 minutes, about 30 minutes each section, and there are lots of questions that you have to go through. 27, 23, 27 or 24 questions. You're gonna have to walk through them all. So you can't focus on one specific question. If you find it difficult, or you spend more than 10 seconds, 15 seconds of trying to figure it out, you're going to skip, you're going to gloss over them and come back to it later. I will explain in a bit when the class is a bit fuller, when Lena comes, but that's essentially what it is. Next up is, right, these are quite basic, so I'm not going to cover it. The y-intercept, briefly mention what a y-intercept is for me. Can you do it, An?
D.
All right, D, correct. Y-intercept is not only just the last digit, it is also the symbol, the negative, the sign before the digits, which is the plus or the minus 4. If you have this equation, y equals ax plus b, you're gonna have to notice that this is by default a plus. So if they put a minus here, it means a plus minus b. So you can carry all of this into this, and you have d. All right. Okay, the 9th question. Can you do this for me, Dam?
I just see.
Right, C. Let's see. The list shown gives the height in inches for the six 10-year-old children in the group. So this is just a redundancy. You don't really have to read this. You don't really have to. On the SAT, there are some things you have to read selectively. If you pay attention to every single detail, you're going to be fooled. Okay. The least they can do to you is to be fooled, and the most they can do to you is to distract you entirely, or to waste your time and distract you entirely. So let's see, a 7th child with a height of 60 inches will be added to the group. Which of the following those will change? So if you do enough, that's why you need to do homework. If you do enough, you will see that this kind of question will be, you don't have to read, you just read here, and you find out that this is the kind of question that at 60, and find out if the mean and median will rise, or it will increase, or will decrease. 52, 53, 60, 54, 55. This is already shorted, so it's going to be a bit easier. The mean will most likely to be increasing because you're adding a bigger number than the rest of the group. So the mean will most likely shift up. And next, the median. Median will be 1, 2, 3, 4, 5, 6, and your plus 1 is 7. 7 plus 1, 8. 8 divided by 2 is 4. So the 4th one is here. The median here, wait, let me briefly mention median. The order of median, the number of median. The position, I'm sorry, this position of the median will be the total of number plus 1 divided by 2. So this is 6 plus 1 divided by 2 will be 3.5. So the median will be here. But if you put a 60 here, will be a 7. 7 plus 1 is 8, divided by 2 is 4. So you get the 4th number is the median. 1, 2, 3, 4. It won't change at all. So median will remain the same, and the mean will increase. Correct? C. Okay, so 7. Can you do this for me, Hung? This is the probability.
C.
Okay, 7C. Did you give out the same answer? Dum? Did you come out with C?
Yes, I do.
Okay, so I want you to pay close attention to these kinds of questions, okay? Because your weakness is what your weakness is about the Lynn is here. Oh, that's early. So your problem in the math section is about the probability, and your weakness is mainly lies within the probability. Probability is not only for the this kind of question, which is you dividing the number by the total, but the probability in your sense is in your weakness is about the statistic. So you're going to have to make sense of statistics, which means the median, the range, and the margin of error. Please pay close attention to that, because I find that you often get them wrong. Okay, so Hung, can you elaborate on 7? How did you come about C?
I took 165 divided by 587.
587. Let's see. A public middle school would be selected at random. So from the 2 counties, what is the probability to nearest hundredth of selecting a school in San Diego County? All right, so they are picking from 2 counties. So this will be the total of 2 counties. What if they say a public middle school would be selected at random from Los Angeles County? What is the probability to the nearest hundredth of selecting a school in San Diego County? Can you answer it? If I replace this with Los Angeles.
That's 0.71.
0.71, really? Because
Yes.
if I say that I select at random from LA, and I'm asking what's the probability of taking from San Diego?
Oh yeah, that's 0.
Exactly, that's 0.
Yeah.
That is how this essentially how the this is structured. Firstly, you get random from where you get the biggest population. In this case, is the 2 counties. Okay, so these are the biggest population. So you take the entire total, you sum them all up, and this is the biggest population. But they are talking about the middle school, so this is narrowing down. Instead of this, you're going to have this is the biggest population in 2 counties. Okay, 2 counties, but in middle school, so you're going to narrow them down into the middle school. All right, so they say if I say the Los Angeles, this is going to be further narrowed down into this section. All right, so if I say that what's the probability of selecting a school in San Diego, it means that will be 0%, because this is the biggest population and San Diego is out here. All right, great. So basically you're just gonna take the population in question, selecting a school in San Diego, divided by the biggest population. Right, biggest population. So San Diego will be 165, and the biggest population will be the total of this, which means 587. All right, so it's going to be C, correct? Great. That is essentially statistics. All right, next one is quick one. Lena, can you do this for me? Just C. How did you come about C?
question is about what for are resident for, and it also suggests that R represents the number of questions answered by each student in group R, and I think that 4R is the total number of the questions.
All right, let's see. So I would assume that you read from top to bottom, right? If you read 430, this, and you read down, right? Is that how you read? Is that how you read or process this question?
No, I read from the equation 4R plus 9 equal to 17.
Okay, so you are a bit selective because there's an equation here, so you're going to focus on that. That's also correct. But what I want you guys to do is essentially what I have been doing for a while, and what I have done in order to finish the math section on time, even earlier, because usually I do maths quickly. And the very secret to it is to read from bottom up. Why is it? Because on the SAT, there's some questions like I'm going to show you later. Some questions that they have the only thing that matters is the last one, and the very last thing, which you have spent like 30-45 seconds reading the entire passage, the entire paragraph, and then they conclude by one unrelated note. So the question in the command in question, which is this one, is the most important one. So this is also how you will ensure the accuracy for you guys. Lina, please pay a particular attention to this, because I find that Lina will kind of have the tendency to make mistakes on simple questions because of this. So when you check your result, you have to check this one, this very last sentence of the mathematics equation, okay, of the mathematics question. This one, for example, if you check, you finish, let's say you finish your test, and then you checking it, you look at this 4R in this context, what is 4R? And then you answer it. And for example, this one is also the slope. You just need to read this, okay? So the equation, and especially for these kind of questions, what is the value of x plus 1? This is why you have to read from bottom up, which is the very last sentence on the SAT is the most important sentence, all right? So for example, this one also, which graph represents the number of bacteria in 1,000 X hours after the initial observation? If you just read the last sentence, you can also just answer it. But if you can't answer it yet, then you're gonna have to do it the other way around. You just read from bottom up. So if the last sentence doesn't give you enough information for you to answer it on itself, you're gonna have to look for it. So 4R, I don't really know what 4R is. I don't even know what is the context. So I'm trying to make sense of it. So I'm going to look up, and I see 4R plus 9 equals 17. So if Lina reads from this one, this part down, but I'm reading from 4R up, from the last sentence up. So I still don't understand. If I still don't understand, I'm going to have to resume and continue to read up, because I don't know what 4R is. I don't know what R is. So I'm going to look what R is. Let's see, where is R? For survey student complied. This one. This R represents the number of questions answered by each student in group R. So I'm having this vague visualization. I just understand this vaguely, that 4R represents something more than just one student, right? So equals 17. I wouldn't matter, because I'm going to check down the ABCD right away, because I have a vague interpretation of what 4R is now. So let's see, the number of students in group R. It doesn't sound correct, because look, R is the number of question. So far 4R can't be the number of students. So it is indeed incorrect. A will be incorrect. And B, the number of students in group V, can it be correct? Because question answer by each student in group R. So it's still incorrect. The total number of questions answered by students in group R, or the total number of questions answered by students in group V. You can see that it is much quicker if you do it as many times as possible. And as you hone in your skills, you'll find that doing like this will ensure your speed and accuracy at the same time. So next time, try, if you see this kind of question, you just need to pay attention to the last sentence or the last prompt, last request, because it's just one-liner. It's just a one-liner question, so pay attention to it. But if you find this kind of questions that has the wording is quite long, lengthy, and unnecessary, sometimes it can be unnecessary because they give out way too many informations. So you're going to have to work from bottom up. Okay. So you're going to see C is the only reasonable kind of question because group R versus V, of course, it's R. All right. So I want you guys to focus one thing. Is the last sentence or the last prompt of a maths question of the mathematics prompt. So the last, it's basically like a summation, but basically like a conclusion of a question. So you can almost like 50% perhaps solved an entire question based on that one sentence alone. So that is the most important one. All right, great. Next up is 15. Can you do this for me, Anne?
A.
All right, that's quick. Can you briefly remind me of what the form of a linear equation?
Y equals mx plus b.
Y equals mx plus b. Exactly. So this is what I would usually do. I don't know if you have other way around, but the thing that I want to look for is the slope first, right? And the second thing to look for is the b. But these two are kind of in an equation. I can make this a system of equation. I'll show you what I mean. I have 2 points like this, for example, like this, 28, 36, and 33, 26. Okay, so if I have these 2 points, can I just put them in a system of equation? Firstly, 36 equals m28 plus b. Can I do that? And the next one will be 26 m times 33 plus b. Cool. So based on this equation, I can just use my calculator and just calculate them based on these 2 values, m and b. I can just type in the calculator and find out that, wait, hang on a sec, 28, 1, 36, and 33, 1, 26. It is -2 and 92. See, this is quite quick. And if you have a calculator in hand, and if you are sufficiently enough in using your calculator, this is how you would do it. But if you can't, you're going to have to result in calculating the slope, the m, and calculating the b, which is plugging in the x equals 0 based on the slope, and then you can calculate. For example, you have 28, you have these 2 points, you guys very quickly calculate that the slope is -2, and you plug them in, and with x is 0, and you're going to have the y-intercept, which is 92, and then you're going to find out a, but that's a bit slower. What way did you choose, Anne? How did you come about this?
So I just did like the rise over run thing. So like the rise is the y is the average amount of money. So then I just like calculate the slope, and I got -2, and then I saw that one was -2.
Oh yes, I forgot. This one is the only one that has -2. So that's a bit quicker. But in a case that when you have I was looking for C and D. Yeah, I was looking for C and D. If you have these two kind of two -2 slopes, you're gonna have to result in calculating the slope by plugging in x equals 0, and you're gonna have b, and or you can use this way using a system of equation. But either way, it's good. Great, that's very good. Focus on the speed. Try. All right, so because our class is full now, I'm going to explain a bit of how you can focus on your speed on the SAT. Okay, firstly, on the SAT, you're going to have to focus on two things. Of course, the accuracy, and of course, it's the speed. Finding the perfect balance between these two is very difficult. And if all of you can do it, it's great and fantastic, and you will get a 1600. But it's not that simple. So sometimes in our minds, we try to get overprotective of our result. That's why we try to reason against ourselves into the wrong. For example, if I get, it won't be as common in maths, but it will be way more common on the reading section. But let's say I think B is the correct answer. I say, well, B is the correct answer, but A also makes sense. A also makes sense, right? So why am I just conflicting myself? Why am I just reasoning? That's because just we trying to get 100% correct all the time. So if I am considering between A and B, and I can't possibly find a way out, even though I spent 5 minutes on this question already, which is way over time. What I will have to result in is to ensure the accuracy will not be 100%. Try not to increase your accuracy to 100%. Don't do it. But what you're going to do is to reduce the accuracy to 90% or to 80% even. So you're going to have to accept that not every single time you give out your answer is correct in order to complete the test in time. So if I give you a test in 45 minutes, you're going to have to partition your time and separate your questions into each time chunk so that you can allocate your time correctly, so that you won't run over time, or you won't be, well, you won't do it too quickly and resulting in lack of accuracy. So either you're going to have to find a perfect balance between speed and accuracy, or you can take a compromise a bit. Speed and accuracy, you can increase the speed on a safe margin. To save margin, for example, you can do it on time. Ensure that you have to do it on time. That is the first measurement. You're going to have to do it on time. And when you find that it's confident for you to do it on time, you try to increase the speed a bit. And you're going to have to willing to decrease the accuracy even way a bit further. Why is that? Because if we do homework and if we do practicing enough, our brain will get a perfect sense of what is right and what's wrong, and our practicing is a bit more effortlessly. We're going to be a bit more quicker, and we don't even know it. We don't even realizing that we are getting more accurate. So this is my journey. I went from perhaps 1480 to 1550 in just one week. Not because I learned everything in just 1 week, because I've learned for 2 months already, but for 1 month already, but I haven't seen any progress because I was always in the 1400 and 1480 range. Why is that? Because I wasn't willing to take risk. I wasn't willing to decrease my accuracy to 90 or 80%. I was trying to ensure 100% my questions and my answers, everything is correct. So I lost the time and I couldn't even do any test on time. I was always short on time or running low on time. That is because I was trying to ensure that my accuracy is 100%. But even when I try to ensure my accuracy is 100%, it won't happen. It ain't happening because there's no one's perfect, right? There ought to be mistakes that happens. So you have to accept the fact that not everything you do is correct, and not every single answer you give out is absolute. So you have to make a compromise on it and have to skip on the other questions, skip on to go to the other questions before you lose any more time. And one thing about maths, and even sometimes reading and writing, is that, for example, if you find a very complicated question like number 19, no, number 19 is quite easy, 21, and you can't possibly find a reason your way out of it, and you're already spending like 1 minute on this question already, and you still haven't found a way out, I suggest reading the whole question carefully enough, to get a sense of what they are, what the question is, and then skip. Don't read it. Don't bother even trying to solve it. Don't even look back and just jump straight to the question 22. Why is that, you may ask? Because once you finish doing 38, or once you finish, you taken off your mind from the question 21, and once you go back, you'll find it much easier to do it. And there's a scientific reason behind this. That is because as you are reading this question, you're directly sending this question into your subconscious mind, which is like basically the back of your mind, so that it will do the processing in lieu of so it will be the background process. It will be the background process rather than the foreground process. So you're gonna have, it's not that you're skipping 21, you're sending it into the background process. So it will be working simultaneously with the other questions, and you don't even know it. Our brain is very powerful. Believe me, that would be very much correct. And next time, try to use it. If you find, or if you encounter a very difficult question, especially on the SAT, because on the SAT, difficult questions are just questions you haven't made sense of. Not unlike Vietnamese national exam. Vietnamese national exam, if you can't do one thing because you haven't learned it, you're dead. You have to learn it in advance, right? So you have to encounter it before you can do it again on the national SAT in Vietnam. That's what's so difficult. But on the SAT, the difficult questions are just like blockage, and you haven't been able to figure it out. So that's why you have to skip on the 21st question, for example, and then you do the other ones, so that you can, your background process, you in the back of your mind can just process it in the meantime. So next time, if you find a question that's very difficult, try not to spend more than 1 minute on it. If on maths, on average, if you can't come up with your answer or the way to solve it in under 15 seconds, it's more likely that you won't be able to do it in 1 minute or 2 minutes. So if you can't do it in 15 seconds, then skip it. That's my rule of thumb. If I find myself being fumbled, not being able to solve this a question, I will skip it under 15 seconds. So as not to waste my time on one question, because if say I can't even solve this when I come back, at least I've solved every other questions. So that's my tip to save your time on doing the SAT. All right, I hope you remember it more, because it's a lot of scientific based junk on it, but you know. Next one is 17. 17, I'm gonna ask you to do it. Hưng, can you do this for me? 17.
17 is C.
Is what?
C.
17 is C. Let's see where you got C. How you got C. Let's see. Okay. How you got C?
I looked at the graph, and that's the only one that that's correct, because after like, oh wait, no, I think I'm wrong. Please, give me a second, please.
It looks a bit difficult, right? It's a bit difficult to look.
I believe it's A.
All right, it's A
Yeah.
is the correct answer because look, it double in number every 12 hours. So on C, it doubles every 24 hours. So you can see that this the initial starting point is 10,000. This is 10,000. But on the 24th mark, on the T equals 24, X equals 24, there will be 20, which is doubling. And this one is like 12 is doubled. So yeah, pay attention to that. Don't be fooled by the simple phrasing even. Okay, the next one is Thumb. Can you do this?
I choose D.
18D. Let's see. Which of the four has the range of 6? So this is the range, right? Just subtract 9 by 3, max minus min, and you have 6. Yeah, that's easy. I'm not going to explain that further. 20, how about this? In which quadrant is the vertex of this parabola? Can you do this for me also, Thumb? Quickly.
I choose B.
All right, B. See, quadrant 2. Remember the order of the quadrants, all right? Sometimes they won't even give you the numbers. 1, 2, 3, 4. Remember, it's in the counterclockwise. Or is it count? Yes, it's counterclockwise. So this is clockwise. They run from a 1, 2, 3, 4, 5, 6, 7, 8. That is clockwise. And the quadrants order is counterclockwise. This is trigonometry quadrant order. So if they don't give you the labels, the 1, 2, 3, 4, you can just assume that it's 1, 2, 3, 4 based on the counterclockwise, okay, direction. So don't get mistaken or don't get messed up by this, or else it will be a bit waste to make this one wrong. Next one is let's see. 24. Okay, 23 and 24. Can you do this for me, Lina? 23 first.
D.
D, 23. Let's see. Scientists took 94 ice core sections from a glacier. Each section was in the shape of a right circular cylinder and has the length of 1 meter and a diameter of 0.1 meter. Which of the following is closest to the total volume in cubic meters of the 94 sections? How can you come about D? Can you explain your choice here? Why did you choose D? Sounds a bit complicated, doesn't it? So you just have to read from bottom up. Which of the following is closest to the total volume? 94 sections.
Calculate the volume.
Yes, can you explain it?
To calculate the volume of one section.
The volume of what? I'm sorry.
One section.
Okay, so you calculate the volume of one section and then you multiply it by
94.
exactly. So this kind of question is the key here is 94 sections. So don't get mistaken at the very last step. So they give you each section. This is not 94, this is just one, right? So focus on the keywords, focus on the phrasing. Each section of a right circular cylinder, and you're gonna be able to calculate the volume of each section, and then you multiply it by 94 sections, correct? Okay, how about 24? You do it also?
24B.
24B, very quickly. 2 is sufficient, but 1 is not parallel. So when parallel, when these, if GH and DE, they are parallel to each other, when these segments are parallel to each other, what do you have from this? What do you have from these two angles, inner angles?
It is equal.
They are equal to each other, right? Because they are opposing, directly opposing each other. That means that they share the same angular value. So if you have two triangles with the same angular values of one angle only, that won't be sufficient enough to be well, parallel to each other, to be similar to each other. But in this case, you're gonna have this also, this and this. These are the inner angles. These will also be equal to each other, and these also will be equal to each other. So focus on these. If you have two parallel lines and one line intersecting the parallel lines, you're gonna have directly opposing angles. These directly opposing angles will be equal to each other. Also, is this one? Yeah, this share the same position. The right, this is both in the right, so they will be sharing the same angles also. And next one will be what is this one will be 2 and 1 will be equal to each other also. So focus if you have two parallel lines. This is why 2 is sufficient enough for DE, F, and DF and GHF to be similar because they are parallel. But once here, why is 1 insufficient? Did you choose B, Lina? I'm sorry. Okay, so you choose B, so 1 is insufficient. Let's say length of DE is 1/3 of the length of HG. DE and HG. Yeah, it's not really enough because you're gonna have to have at least two ratio of length of triangular length. Firstly, you're gonna have to have GH and DE is given, and you're gonna have to have GF over FE or HF over FD also in order for this to be sufficient. So one side is not enough. You have to have 2 or more. So B, correct. All right. Next one is yeah. Oh, this one. This one, can you do it on 30?
E.
B. Why is that if there are more visitors, there'll be A will have a larger margin of error? Why is it?
Yeah, because if there's like more samples, there's less like margin of error.
Exactly. So the margin of error is directly in proportionate to the disproportionate to the directly proportional, I'm sorry, to the margin of error. So you have a larger sample size, and if you have bigger sample size, you're going to have a smaller margin of error, and vice versa. Of error, and vice versa. So this is a directly proportionate kind of relationship, right? Very good. B, and next one is, do you have anything down here? Right, this one is kind of simple. What you're going to have to do is take the average speed greater than or equals to. It's going to have to be from here to here. You just plus sum them all up. You have 144. Okay, next. All right, this one is fun. Can you do this, Hung?
Three.
Okay, it's what?
Three.
3. Right, let's check. How did you come about 3?
I calculated the mean of additives
What is it?
additives attempts. I calculated the mean of additives attempts.
So how much is it?
and
How much is it? Additive?
3.9.
2.9. Right, how about
Um,
Bella?
then I take 3.9 plus 0.3, that gives me 4.2. And I take 4.2 times it by 5, which is the number of integers in Bella's attempts.
Yes.
Then take that number and then subtract all of the rest from Bella's attempts. That
All right.
leaves me with 3.
3. Let's see.
Yes.
4.2 times 5 subtracted by 4.4 plus 3.7 plus 3.8 plus 4.6. I still don't
Wait.
get 3.
I mistyped. It's 4.5.
Okay,
Sorry.
exactly. So it's 4.5. Right, correct. So don't mistype because on the SAT is very dangerous. All right. 37. Can you do this for me, Tom?
Oh, sorry, I forgot to turn the mic. So I have the formula of the height of an equilateral triangle is a square root 3/2.
Okay, for A is
A is the side of
side length.
of the triangle.
Okay, so on the equilateral triangle, which is the triangle which has 3 equal sides, the side length would be A and H is the height, right? H equals A square root of 3/2. All right, so what next?
So from the formula, we have the side length of is 10 per side.
I'm sorry, could you repeat that? So you have H is
H is 5 square root 3.
okay, 5 square root of 3 equals A square root over 2,
10.
right?
Yeah.
So it makes 10. 10 equals 8.
Yeah.
So how can you calculate the perimeter?
I multiply them by 3. Multiply it by 3.
Okay, you just multiply a by 3 because the perimeter is basically the length of the outer sides. So it's 3 times 3 because the equilateral, remember, they have 3 sides equal sides. So instead of plus adding 3 sides together, you just need to multiply by 3. So it's 3 times 3 is 30 exactly. All right, great. Now we will learn something about graph manipulation. This is what happens when you manipulate a graph. All right, firstly, let's start off with this one, 14. So let me just introduce you a bit to the graph manipulation. That is very simple. It's just if you add fx, if you add a delta, or let's say 1, let's round it up to 1 so that it will be easier to understand. If fx plus 1, it will shift the graph up by 1 unit, and minus 1, it will be shifting the graph down 1 unit. If you, on the other hand, add 1 to the x, it will shift to the left, in contrast to shifting to the right of minus 1. So this will be easily mistaken, right? So remember, fx plus 1 is to the left and minus 1 is to the right, right? So don't get mistaken by this, as I have done so, and I've seen so many done so over the months. And yeah, that's basically it. Essentially, what graph manipulation is, you just add 1 outside of the whole equation, which means fx plus 1 is moving up, fx minus 1 is down, plus 1 in the x is moving to the left, and minus 1 to the x is shifting to the right. Right? This one will be a bit contradictory to popular belief, because people assume the plus 1 is to the right and the other way around. But remember, plus 1 is to the left. Okay, so now I want you to do this one, Lina.
It is A.
Let's see, A. So currently, what is the y-intercept of this one?
2.
2, right? So if you shift the graph by 2 units to the, where are you shifting it? To right or to the left? Left, exactly. You're moving this to the left 2 units, which is moving this up 2 units here. So you're gonna have to shift this up to 1 and 2. So this will be the new y-intercept, and it will be 3. Exactly, very good. And this one a bit more tricky, but it's just essentially very simple. Can you do this for me on? Let me just zoom it out. Yeah.
I wasn't sure how to do 11 because I don't like I wasn't familiar with the science stuff
No,
as
12,
much.
the 12 one.
Oh, I think I chose A.
A, let's see. Firstly, how did you come about A? Did you just circle this out and then +1?
I plugged in x 0,
X equals 0, and you get
2.
2, exactly, because 2 to the power of 0 is 1, plus 1 is 2. All right, so you're crossing out what?
B.
B. You cross out B, and then
D.
D. Let's
Wait.
see. Wait. Why did you cross out D? Did you have 2 in it? So just remember the shapes of the exponential equation. You're gonna have, firstly, is this one, is the exponential growth equation, exponential, and this will be the decay, exponentially decay. All right, so these will be like the decay and grow. But what if you don't remember the shape of the equations? You just plug in the other points. For example, just try -1. -1, what will you get?
Three.
So -1, you get wait. Yes, it's 3. So it's 3, and so this will be here, right? Firstly, you have 1 point is 2, and next you have the other point is 3. So where will you circle out? Where will you cross out?
CD.
Exactly. You just have to plug in more points in order for it to be a bit more accurate. But one other way is that you can use the graphing calculator. On the SAT, on the digital SAT, which I will show you. Hang on a sec. You have access to what called a graphing calculator. Wait, let me just open it real quick. I will guide you how to use this. Okay, this is the program that the SAT is borrowing for the digital SAT is Desmos. They use these exact programs to integrate it into the Blue Book app so that you can use this. But if you have, like say a graphing calculator, like a Texas Instrument TI-84, I believe, you will also be able to use the graphing function ability within built-in. But if you don't have the graphing calculator, you can use this. So where will it appear on the Blue Book? I will explain further as you go down the line of actually taking the practice test. But first, you can see that you can have this exact interface on the Blue Book SAT app. You can type in x equals. This makes the question much easier. So you have y equals 2 to the power of minus x plus 1. And you have this shape. And it's very simple. If you don't know how to do it, you just type it in. If you don't know how to plug in the result, the solutions, you're just gonna have to type it in because it's very simple. It gives us the shape, and yeah, you say you're gonna have the y-intercept of 2 and the 3, 4. It's a 3 here. See, -1, 3, and that's essentially it. It's very simple, and you don't really have to think much when it comes to this kind of questions. And about 3, so whenever you encounter a graphical questions, either you can plug in so that you can ensure the utmost accuracy, or you can just use the graphing calculator built in on the DSAT. So from now on, when you do homework, just open up this website, desmos.com, here on the screen, desmos.com, so that you can just try this graphing function before using the blue book, because it's your right. You can use this. All right, back to our lesson. Sorry. Okay, so that's essentially it. And about the 11th question, it's very simple. You just need to use your calculator. If you don't know how to use it, just type in sine. If you don't know how to turn if you don't know how to put your computer into radian, you can just convert this into degree, which means you use 3/4 pi times 180 divided by pi, which means you just take 3/4 times 180, and you get, let's see, 3/4 times 180, and you get 135. Sine of 135 in this will be square root of 2/2. This section is supposed to be a non-calculator section, but you can use your calculator for every module now. So I'm not going to make you to use your hands or use your calculating ability, because I know that not even myself can remember such thing. Okay, so this is essentially it for this test. So we're going to walk through some notable questions on the latter examination, so that we can break. May International, there's just a handful of questions. Firstly, returning to this kind of questions, can you do this for me, Ho? You just have to read the last sentence and you can do it.
D 14.
14, exactly. Just here is 200, meaning doubling. The initial starting point is 100, so doubling it will be 200. It's here and down, and you get 14. 10, 12, 14. Exactly. Next up is this one, a bit too simple. No, yeah, it's too simple. 12. Can you do this for me, Tập?
It's B.
It's B. Sine of 50 equals cosine of 90 degrees minus 50. So you get cosine 40. Exactly. Next one is, okay, you do this also. All right, what is this essentially asking is very ridiculously overstated, because this question is very long, and as you can see, you read from the bottom up. And let's see how Tom would do it.
Actually, I choose D.
Okay, D.
Yeah.
D. How did you come about D?
So we have the I don't know what to say, but I wrote that for $60 we have 18 hours, and for $5 we have 8 hours.
$5 you have what?
8.
How much? 8 hours?
8 H.
Okay,
letter
H hours. Okay. The letter H.
Uh,
8 hours.
So I have H equal by multiply with 18 over 16.
Okay.
And then we take the 5 out and have 16 over 18 h equal 5.
Exactly. So this is ridiculously overstated because look, Kiara uses her propane grill for an average of 11 hours each week. One redundant. Her grill can run an average of 18 hours per 20-pound tank. Two redundant. So I'm just using 16 hours, $16 per 18 hours, right? So you can see it's just phrasing. 18 hours per 20-pound tank, but $60 per 20-pound tank. So essentially 18 hours per $16. And if Kiara would like to reduce her weekly expenditure by $5, she would have to know how many hours she would have to reduce. So $16 equals 18 hours. How about $5 equals what hours? So you're just going to have to use the cross multiplication, which is 5 times 18 divided by 16 cross and side, cross and side. So cross multiplication is 5 times 18 divided by the side is 16. You get this one, and then you just divide by 16 over 18 over 16. So you get 16 over 18 equals 5. Yeah, very simple. It's just phrasing. It's very convoluted, very complicated. It's just phrasing. Okay, next up is there's some better questions down here. Let's see. All right, 25. Lina, your turn.
Choose A.
Right, A. How did you choose A?
We calculate the probability to selecting shaded square, and it is 60 over 100, and after that I minus the probability of selecting a square that is not shaded, 40 over 100.
All right, exactly. So you have 60 squares are shaded. So how much greater the probability? So you're going to have to calculate the probability of selecting a shaded square and then subtract to the probability of selecting a square that's not shaded. So you calculate these two values, and you subtract from 60 subtracted by 40 over 100, and you get 0.20. 0.2. Exactly. Very good. That is actually statistics. In isolation, it's very simple. In isolation, it's very just basic. But in unison, when it comes to doing the entire section, every single section at once, it'll be a bit more difficult because you will get tired and you won't pay attention to details enough as doing one single question. So pay attention every time. When you do the SAT, you're going to have to concentrate a bit more. Don't be distracted. And that's how you're going to get a high score. Don't be distracted. 28. Go back to Hung, shall we? Can you do 28? Can you briefly mention me the the volume equation of a sphere?
R squared times pi times h.
A sphere. You sure? R squared. A sphere. When you calculate the volume, you're gonna have the R cubed times what?
R cubed times pi
Times what else?
um 4/3.
Yes, exactly. R cubed pi times 4/3. So it's the radius of Mars. What you're gonna have to do is calculate the volume of Mars. It's very big, and you just subtract it by the volume of the core. The volume of the core basically the 1/8 of the volume of the Mars, because the radius of the core is one half. So 1/2 cubed is 1/8. So you're gonna have D, right? It's very simple, but just lengthy in calculation. Let's see. Let's do this one. Can you do this one, Anne?
Uh, I got 10.
All right, 10. Basically, you just need to read the last sentence, right? During the trip, how many times the passenger instantaneously fueled at least 34, but less than 36. So 34 is here, 36 here. Just add in 6 with 4 here. So it's very simple. This is a one classic example of the last sentence is the only thing that matters. This one is junk. It doesn't matter. This is a junk prompt, and it's just a distraction. If you pay too much attention to this one, you're gonna waste a lot of time. That's why you need to read from bottom up. The first thing I encounter is during the trip, how many times did the passenger record an instantaneous fuel economy of at least 34, but less than 36? So I would say I don't know 34 and 36 where these are, but I can see the graph. And then let's assume that I read the graph, okay, and I see that 34 is here, 36 here, less than 34 and more, less than 36 and more than 34, so it will be here. So I don't really need to read this. It's very much wasted. And you have 6 and 4, and you add them up, you get 10. Exactly. It's very quick if you know what to look for and where to look for it. And the rest won't matter too much. All right, last question. Can you do it for me?
I choose D.
D, let's see. How can you find the median?
I have the sum of the frequency and I divided them it by 2.
Sum of the frequency divided by 2.
It's
Are you
10.
are you sure dividing by just by 2, or you're gonna have to plus 1? Okay, so you add them all up, which is the frequency, and you plus 1 and then divide it by 2. That is the median. Okay, so let's recalculate and see what is the median.
It's 10.5.
Yes, 10.5 is the position of the median, right? So you will take the 10th number and the 11th number, you add them together and you divide it by 2. So let's see, what is the median?
And 25.
Can you find me the 10th number? What is the 10th number?
No, 20. No, 5.
10th number is 25, right? So this is 4, 6, 7, 4, 6, 4, 5, 6, 7, 8, 9, 10, and 11. So 10 and 11, they are both within this frequency range and within this value range. So they are both 25s. So essentially the mean doesn't change when you plus 1 or minus 1, but sometimes it will. So be careful not. And 25 is the median. And how about the mean? What is the mean?
The mean I took 10 multiplied by 4 plus 15 divided by 3 and so on, and all divide by 20.
20,
Yeah.
yes.
Um,
And you get how much?
I have wait. I miscalculated. I have 21.5 now.
Okay, exactly. 21.5, exactly. And what is your final decision?
B.
B is 3.5 greater than the mean.
Yeah.
Yes, exactly. 3.5, right? So it's not D, it's B. Okay, great. The second most common mistake is the miscalculation. So don't miscalculate, all right, everyone, be careful. And when you check the answer, remember to check the very last sentence. What are they asking about? And then you can conclude your answer is right or wrong. Okay, that's it. Do you guys have any other questions for today's lesson? All right, if you don't have any other questions, I would dismiss the class right now. And I wish you a good day, and I will see you again soon. Goodbye.